So this is a tutorial about getting a surface that is self-building. It's like self-constructing out of nothing, or like from underneath the object. I'll also show you that. And it's a really cool thing that you can do now in Blender 3.1. By the way, I'm using the latest build of 3.1. That is the build from January. I have a model, just a man. I didn't make this model, but it will work to illustrate our point. And first off, I'm going to create a curve. So Shift A, curve, Bezier, there it is. And I'm going to move this curve into a position I'm comfortable with, basically where I want the effect to take place. Okay, so I'm just going to move things around a little bit. Make sure these handles are not too wacky, because they do matter. They will matter in the end once we get there. Shift 0 let me actually see through my mesh, so I can actually pin this a little bit better. Maybe I will subdivide this, and that will give me a point in the middle, which I can shift, so we're generally going towards the curve of the arm. Okay, so now I have my curve selected. I'll go into the GeoNode setup, and in the geometry nodes editor I will just click on new, and it will appear in my modifier stack. That's the geometry node. So the first thing we're going to want to do is resample this curve. Or maybe first we should talk about what's actually going to happen now. Basically, based on proximity, this is our curve and this is some face on our mesh. We will use the closest point on the curve in order to take some data out of it. In this case, we will take data about the radius at that point, and we will use that to do some funky stuff with our mesh, basically. So the problem is that to do that, there is a transfer attribute node. However, it does not work with splines, which is bizarre because it works with point clouds, right? But it doesn't work with splines, which are just a series of points anyway, but I digress. So in order to get through this, we will just convert our curve into a bunch of points. So there is a function for that. It's just called curve to points. Okay, and then we want to embed into these points some value. We want to embed the radius of our curve at different points into these points, and that is done with the capture geometry node, which stores information inside the geometry. And what I want to store is the radius at the curve at that point. So let me just clean up my doodles. Next, what we want to do is we actually want to spawn the things we're going to be moving on the surface of our object. I'm going to disconnect this thing real quickly, and for that we need to bring in this object into our modifiers. I will just get an object info, and from over here I'm going to pick my basic man model, although do be aware that ultimately you want this to be in your modifier stack so you can connect it up from your group input, but I won't do that right now. So that gives me access to my geometry. This needs to be set to relative so that it respects any transformations done to the actual model. And then what we want to do, I'm going to actually hide the model in the viewport, and if I plug it out here, I'm going to see it through my curve. So then if I hit this with a dual mesh, this will basically, if I turn it on and off with M, turn every face into a vertex and every vertex into a face. But the cool thing is that if before this you plug in a triangulate, you will actually end up with this hexagonal pattern, and that is pretty much what we want. So with that in mind, what I'm going to do next is I'm going to just split these edges so that each one of these faces is its own unique thing. So split edges, and nothing has happened, but they're definitely separate now. And what we want to do is we basically want to move all of these objects away based on our curve somehow. So to do that, what we have to do is first off get the distance from each point to our curve. To do that, we will use the transfer attribute and also the geometry proximity nodes. Okay, geometry proximity. So the geometry we're going to be testing is this line. It is made out of points, so set that to points. And over here the attribute we're going to be transferring is again coming out of here, and the attribute is this radius. We want to transfer it based on the nearest point. And what we have now is essentially this is the radius of the closest point. And over here we have the distance to closest point. So this to closest, you know. So if we know these two, we can actually create a little rule here with math. We'll say if the distance to the closest point is greater than the radius to the closest point, I want you to delete those points. Okay, so right before all of this, right when we brought in our geometry, I will do a delete geometry, and this will be my selection. Now I hope this does work. It does work, as you can see. Problem is that the radius of the curve by default at every point is 1, which is 1 meter. So if I select my curve, any handle, press T and select the radius, I should be able to scale that down, and indeed I am. You can see how now we're already getting our effect here where the curve is controlling where our objects are appearing. And at this point maybe I will bring in the original mesh underneath. You can kind of see both of them. And with that we are on our way. Next we need to talk about how we're actually going to push these objects away. So to do that we will use this distance to also create a mask. Basically, if we use a map range, and if we plug into, if I plug into this map range the distance to value, and then I plug the attribute to maximum, but also another version of the attribute which I will subtract a certain value from, something small, and I use that as the to minimum. What that will do essentially is if I have a point here, just give me a second, if I have a point here, right? Oh, you can barely see that, huh? If I have, okay, so if this is my spline, and this is the last point, and there's some geometry here, what I'm going to do is I'm going to take the distance from this geometry, let's call that D, and we can think of this as like an area. Oh no, this is fine. The distance from that point, but there's also another distance. Let me draw this a bit closer. Distance from the last point over here onto one of my vertices of the face. But there's also another thing here, which is the radius of this plane itself, right? So we'll call this R, we'll call this D. And then what I want to do is take this distance value, which is from 0 to something, x, and remap it so that from a certain value over here, from a certain range, which is just the radius of the spline at that point minus something like a, and remap that from here to here so that it goes between 0 and 1. Okay, so essentially r minus a, that is this node, radius is just this radius of the closest point, the distance over here is just this distance, and then this mapping range node does exactly what I explained over here. You know, we're plugging in the radius as the maximum thing to map over here. That will be equal to a value of 1 maximum, and the minimum over here, which is just the radius minus some amount, that will be the minimum 0. And what I'm remapping is the distance from the scene. Okay, I hope that makes sense. So basically what that lets me do now is, if I use a translate, or rather what was it, set position, I think. If I use set position and then I move everything along the normal, first of all let me explain that, because we have currently a bunch of faces, hexagons, and they're like on a surface, right? If this is an arm, they're on a surface, and the arm also has a normal at every point that's pointing away from it, and I'm basically pushing everything with an offset that is the normal. However, the normal is always 1, so it's pushing them 1 meter away right now. To stop that, I will use a vector mat, which will let me scale this vector down. So 1 meter, now it's less. See how we're pushing everything? And now if I just plug into this scaling, the map over here, the map currently goes 0 to 1, and I then plug this through a mat node, just so we can control that. I can now adjust at the end over here. You can see how they're moving, and if I change this amount, which is where we start to remap from 0 to 1, we will see that now we're pushing them from a bigger distance away. Okay, basically if I change the radius a little bit, this point has too big of a radius, and over here basically you can see the effect is already taking shape. Now I can sort of move this around, and I don't like how this handle is well over here. Yeah, we can see how as we're moving this away, and I can change the radius to just sort of move everything like this. There you go. So that's pretty cool. Yep. We're already basically done with most of it. However, we can change the way this moves because it's very linear. I would just take this map and use a map node to give it a power, because that will taper off. If I say very high power, you will now see how now the different pieces are sort of coming in a curve, not so linearly, because that's what the power node does. It turns linear transformations into like this soft thing. Okay, so that's pretty cool. Now we can do that. However, how do we get them to scale? Well, for that we're going to use the, I think the new one, it's called scale elements. So this is 3.1 thing, and basically I'm going to use the exact same mask I got here, but I'm going to modify it differently. So like this, plug this into scale, or rather, no, I messed up. What I actually need to do is I need to subtract this from 1, because remember the map goes from 0 to 1 at the center, so if you flip that, everything here has a scale of 1, and as it appears it has a scale of 0. So now you can see how my geometry is kind of appearing out of thin air. If I move it, it will be more, there it is, appearing out of thin air, and it is styling our surface pretty well. What else? We actually need to talk about the material. That's not too hard. After we have scaled this element, just set material. I will go into the shader, or rather into here, add a new material. I'll call this something like new surface. We can make this blue, give it maximum metallic, minimum roughness, or something like a low roughness, and then I will plug it in over here, new surface. If I then go into my shader preview, I can see now that my things are indeed there. However, it's important to know that since I used triangulate at the start, this actually reduced the volume of my mesh. So now there's certain areas that are just clipping through. To fix that, after the geometry nodes modifier, we're actually going to plug in a Solidify, which will actually give some volume to these things. And I can select the thickness and an offset as well. We probably want, yeah, we want a positive offset. And now over here I can actually select the thickness of these new pieces, this surface. And yeah, this does look fine. If I now select this, I am able to move it around, and that's basically the most of the effect. Now I do need to warn you that as I increase the radius, for example if I go into main, as I increase the radius of this point, eventually it's going to stop working at around over here. The reason is because this is using proximity to the closest point, so the closest point would be this one over here in the elbow, and I would need to increase it from here, and then it would be this one in the arm. But the easiest way to fix that is just to add more points. So instead of scaling the radius infinitely, I'm going to, just 1 second, I'm just going to press E to extrude this into another, just to continue the spline. And now this has again control over this area, and you can keep pressing E, changing the radius, and you can get some pretty cool effects going like this. Okay, so that's great for hexagons. If you want just a bunch of hexagons on your surface, it's fine, gets the job done. However, what other shapes can we do? If we go into the geonodes, where did it go? So this is my Solidify. I'm not going to Solidify for now, it just slows me down. I prefer performance at the moment. What else can we do? Well, if we just remove the triangulate, if I press M to mute it, this will all become squares. So now you can do squares. And if you remove the dual mesh and then add the triangulate, these will all become triangles. However, for some reason it shade smooths them. So right after or before the material, just set shade smooth, and you want to turn that off. That will make them sharp again. And I saw the same thing happen when I used the squares. So yeah, these are the 3 shapes you can get really easily. And since we're using the topology of the model, we need to keep that in mind, because the topology will basically dictate the size of these points. So that's a drawback, but a plus is that this will now work with animated characters. So for example, if you want this guy animated, you would just put this thing. I mean, yeah, basically you don't have to worry about it. It would just work, because when the topology deforms, the size of the pieces will scale appropriately, and they will also deform appropriately. So yeah, that is that. So let's talk about ways to actually make this even better, because currently it's all great and good to use hexagons, squares and triangles, but what about a custom shape? Well, to do that, I'm just going to go ahead and copy this geometry node, and then I'm going to delete this on the copy. I am going to delete everything except the mask and this greater than, which I used. So go ahead and cut all of that out. Everything past the mask as well. So this is all we're left with. And instead of using the geometry itself, we're going to just instance on points whatever object we want. So in this case, I'll just go with a box. I mean, how do I do that? Cube. Just go with a cube. Plug that into the mesh socket, or rather the instance socket. And now we want to actually bring in our object. So object info, again basic man model, again relative, and this will be the geometry we'll be spawning our things on. So if I plug that out, currently it spawns a cube for every vertex of my mesh, and that's why it doesn't look that great. But what I want is basically the size of these cubes to be dictated by the area of the face below them. So there's a node for that, it's called face area. However, this is very waggy, so I'll just turn it off for a second. Straight up plug this in, and then all the instances should disappear. This is because by default the face area is very tiny. Okay, to fix that, we're just going to do a math multiply, and I will give it some huge number, very big, and now you can see they're appearing, and their size is dictated by the face area. However, you realize over here where we have very tiny faces, the cubes are way smaller than they need to be. To fix that, we will just use a map range instead of a multiply node, and then we will set a custom maximum so that the big faces look fine, but also now we can set up a minimum, which has to be pretty low, 0.001, and that will let us scale the smaller faces up. Basically we're eyeballing it. So that's great. What I can do then is I can align everything with the normals. So align your root vector, plug that into the rotation, get the normals of the surface as the vector, and I'll align the Z up. Now you can see how all my cubes are sort of aligned. See, without this node and with it, they're aligned. However, I also want to align one more axis in order to be able to rotate things later. So another align UR, and what I need to align with is the tangent of my curve. So remember, my curve has normals that are going away from it, just like my geometry, but it also has a tangent going towards the end, and that is at every point. So once again, I need to capture that as an attribute onto my curve to points, my point cloud. So go ahead and duplicate the capture attribute node. What we're going to capture is the curve tangent, which however is not a float, it is a vector. Plug that in, and now I have access to it over here as soon as I plug it through another transfer attribute node. So I get this transfer attribute node here, set it to, or rather not into source position but into attribute. Once again, the geometry here would just be my point cloud, and if I just set it to nearest point, because that's what he's going to be using, and set this over here, set this to X. Now it will align the X, but I want it to rotate around Z, you know, because I already aligned the Z. So if I say align the X by rotating on Z, I don't even know how to explain this, but basically if this is my surface, right, it has a normal. I just, with the first node, I aligned my cube so that it's facing the Z is up, right? That's what I aligned. And then with the second one, I aligned my cube such that the X, which is currently pointing in whatever direction, is actually aligned with the tangent of the curve underneath. Okay, so this is my surface. I don't even know how to represent this as a surface. But with the tangent underneath, which is like this, and I did that by rotating it on Z, which means that now this is pointing sort of in this direction. Okay, because if I didn't anchor this by setting the pivot point to be Z, it would basically, like I don't have this node, it will ignore that. So we want to anchor this on the axis we aligned at the start, so that it doesn't just, otherwise it would just do this. It would set the X to point to the tangent and the Z would probably get messed up. Hope that makes sense. Okay, so now that we have this, we're basically good to go. Let's first set up this cutting here, because there's way too many. So just select this output, put it into selection, and it might need to be less than in this case. Yep, there we go. So again, I will also delete some of these points, there are too many. Yep, there we go, now it works. We're basically spawning instances this time instead of creating geometry. And I think I'm going to have some coffee now. You can't see this, but you know. Okay, my coffee went cold. Okay, so where were we? Right, after this we have a bunch of instances, right? We want to move them the same way we moved the surfaces before this. So to do that, what we're going to do is translate instances, and we have our mask again. So basically the same thing, plug this through a math, and what we're moving them on is the normal. So we want to scale that normal using the, using the vector math scale function, just like this. And now if I reduce the radius here, I should see this coming into fruition. The problem would be never mind, not by the normals. See, this is why I rotated everything along the normals the way I did. Because now if I just show you, the Z direction is already aligned with the normals. So I'm not going to be pushing on the normals, I'm going to be pushing just the Z. And I do this with combine XYZ, plugging this into Z and then Z into vector. And now we have that effect that we wanted. We can just set it up so that as we're moving away, the cubes are also getting pushed away. However, I used an add instead of multiplying, that's why it's being weird. And there we go. Now we can see that it's moving, and it's a negative value because I'm intelligent. There we go. Finally. And this is pretty much the effect. Now we're using cubes instead, which is pretty cool. Pretty cool. Now you'll notice that the rotation is pretty random though. It's pretty random. We want to align that. So we didn't have to do that before, but now we do. So rotate, rotate instances. And basically the same map. However, what do we want to rotate on? First we can check that. If I look at all of my instances, that's not quite it. On the Y, yeah, I can rotate them on the Y. Actually, you could have rotated on the other node thing. I totally forgot to mention that. But yeah, another combine XYZ, we're rotating on the Y, so we want to plug our map into Y with a modifier so we can control that. And now, as they get closer to the end, or as they're coming in, they will also be rotating in whatever direction I want. So yeah, you can see they're rotating as they're coming in. I think that just gives a sweeter effect. Probably wouldn't go past -1. Yeah, that is a big part of it. I'm pushing them a bit too much now. And once again, it's nice to have this map range go through a power node, just to get a more interesting transition, not something this linear. So power like 4, and that's actually better, at least in my opinion. You don't have to agree with it, whatever, I don't care. Okay, so what else? We talked about rotation. I guess we also need to scale them. It's literally the same thing. Scale instances. It's literally the same thing. Although no need for this. We just need to take this map and just plug it through a subtract to flip it. Subtract from 1 to flip it right here. And there we go. Now they're also coming out of thin air. So that's pretty cool. That's pretty, and yeah, I can give it a material. Set material, once again, the new surface. There we go. That's pretty cool. What else can you do? You can, instead of having them coming in from space, have them coming in from underneath the surface, which is a bit trickier to do. I haven't been able to really make it look that good, but maybe you'll do a better job than me after I show you how it's done. So what we have now is 0 to 1 transformation, but here's a fun fact. If I just do sine and then scale that sign by just changing the A like so, and a control for that A, we can see how I can actually get negative values out of my map. And if I set this to 0.2, something like that, we'll get this sort of map. So let's do that, because we'll see what happens. Just math, take this, multiply it, and then just plug it through a sine function like so, and then I'll use that here, although not like that, it will go over here through a multiply. Oh, divide, not multiply, divide. So divide by something like 0.2, and then I need to change the push a little bit. Again, 0.2 is good. And now if I move this, you can see how it's sort of coming in from underneath. Like there's a wave going through that is adding our geometry, so I think that's another cool effect. Yeah, it's sort of creating a little wave, which is pretty interesting. But other than that, you can also, if you want them to make them look like they're really coming in from underneath this geometry, what you can do is you can also move them on the X over here, which is just forward and back. However, you want to plug this through a float curve, which will basically let me create make this 0 to 1 transformation into any curve I want. So I'll plug this through another multiply node, and then I'll plug it into the X. And if I have a curve that is like this, another point here, if I select this point and set it to sharp, I'm just showing you what I found that works. And if I move in underneath, you see it looks like they're coming in from below even more, and this value controls how far back they go. Yep, I will probably decrease this push. Yep, that looks fine. Now you have like a wave and the chunks are coming in from underneath. Again, if I add the rotation and the scale, it should be even better. But yeah, that is one way to do it. Now it's like a shock wave. Really, you can have a lot of fun with it, because as long as you have this range over here, you can do whatever you want with it and control different variables afterwards. I just want to show you that. And yeah, so these are the two ways, and now you can instance whatever you want. For example, instead of a cube, I can put in scales here, or I can put in an icosphere for whatever reason. There you go. That looks pretty dope. But if you wanted more coverage, you would still use the first method which we showed, because this one uses the actual geometry, and you can see it covers everything more tightly than the second method, which can have holes in it at certain locations. So I'm just giving you both of these methods. And over here I forgot that we can also set the rotation, although maybe there's no point, I don't know. Let me see. So that's all I wanted to show you, and this totally works with animation. Just you can rig this character, and however you would also need to animate the curve along with it based on proximity. And I tried to do it with distributing random points to the surface, but that didn't work with animation because it constantly kept redistributing them. Also, another important thing I forgot about this should be set to length. We should be resampling over here based on length, and a pretty small length at that, like something like 0.01. This is important for accuracy later on. And after you do that, you can also trim your curve. I believe if you just go trim curve over here, you can trim it, and that will give you this cool effect. You can just basically animate the length of it. And the finishing touch would be pretty much just taking everything here and just plugging it out to your group output, things like the strength of the push, so you can control it from the modifier. And you would need to do this. I'm just not gonna bother right now, so this tutorial doesn't become too long. One more thing, if you look at this in cycles after the fact, this is with the first method where it uses the topology. You notice that it's looking a bit jank. This is because we gave it a set shade smooth. To fix this, after the Solidify modifier, we want to give it a bevel, and we want to set that bevel to something very low, like 0.01. And then we also want to limit method none, and in geometry we want to set clamp overlap to just don't clamp the overlap. And in this case I'll need to reduce this even more, if I want to get those really crisp edges. And there we go, and also segments to 2. And now you can see how that fixes up the shading. Yep, yeah, again, it'd be great. I'm just shouting this out as ideas into the void. If this thing could sample curves, because there's no reason why it can't, if it can sample point clouds. And also, this is actually a sample curve node. If this can work based off of distance, or if it can also have the radius and the tilt as parameters, I'm just saying that'd be really cool. Okay, bye.